I like our matching butterflies.
Yeah, that's cool.
Yeah, let me just silence it. Okay. Well, we had a short medical podcast um yesterday. We did not have our non-medical podcast, Misha.
Yeah.
And surprisingly, Amanda is not with us.
Wow.
It's just you and I. Wow.
I think she is somewhere else.
Yeah.
Enjoying the sun, definitely.
No, she's actually attending the graduation celebration of her sister somewhere in the East Coast. Now, there is a reason we are doing this podcast, only you and I. And you want to describe what was the starting point of this conversation?
So I think it started when we were trying to fix the compressor in the garage, and we find out that it's leaking. It's not properly sealed, and we find out the reason for it's leaking. It's because malfunctioning of a small plastic piece, right?
Yeah, it's where it see the compressor actually. I can actually share my screen here. Let's go back here. It is, I have this compressor and I have it for 8 years now. And it actually works pretty well.
8 years?
8 years, yeah.
Oh,
no, actually more. I moved here about 10 years ago, 10 years. And you know, it's eventually this part is one of the gouge is broke and I repaired it. I took a gouge from a medical device. Actually, a gouge, you see the upper gouge there that shows what the pressure is? I took it from a medical device and installed it and has been working since then. I did that 5 years ago. And then just last month, I noticed it's leaking. It's running. I noticed it's running all the time. And when I went there, I noticed it's leaking. And then I start taking it apart and looking at that. And I noticed that behind this, I took this metal piece off. Behind that, there is a small little switch. That little switch, let me see if I have a better picture to show you that switch here. Here, that switch here, practically what it is, the compressor creates air. Part of that air get through this hole here. Most of that goes obviously to the tank. Part of that comes here to this switch, which you can adjust then after you reach certain level of pressure, it turns it off. Okay. So it doesn't keep, increasing the pressure and so on and so forth.
Oh.
So
that's the reason I was hearing like sounds coming off the machine.
Yeah.
I think a couple months ago, I thought it's going to explode.
Yeah, because it was probably just keep running and running and running and not stopping.
And it's leaking, so it's kept itself running.
Yeah, because it's leaking, it's keep itself running, exactly. Mm-hmm. And now, practically, I took this apart and I found out that pressure device, which is number 31, where this piece of metal, literally, there's a piece of metal that we looked at here. You see that piece of aluminum-looking metal that coming there?
Yeah.
That bring the pressure here, and then it literally regulates itself. Now, where this piece of metal goes to this pressure device, I thought this is the problem. I opened it up, and by the way, they have built it so in such a narrow space. It is not a trivial task to take it apart. And then to take it apart, to have a space to open it up, I had to take the plastic piece around the engine on top of the black piece. I had to take it off. But I noticed that they have put special kind of screwdrivers there. So you cannot open it with a regular screwdriver. And it's not the Allen, it's not the Phillips, it's not a regular flathead. It is a very specialized star screwdriver. And to my advantage, I have those special kind of screwdriver, so I could take it off. Once I took it off, I start taking that aluminum piece off. So they have made it really difficult to take it apart. And first of all, if you notice any design in 1950s and 60s, they are built to take it apart so easy and put it back together so easy.
So you're just the camera.
Yeah.
There you go. Okay.
So,
you're back.
and what I've noticed that at least since 1980s, they make it on purpose harder to take things apart. They add special screws. They add the specialized kind of connection that, and in a very, very awkward position, literally, that you need specialized tools to take something apart.
Yeah, same way when I was growing up, the cell phones, you can take off the battery,
Mm-hmm.
and now you can't do it anymore with iPhones.
No, not
or any smartphones.
Well, yeah, I think
It's
Androids
incredibly difficult to do so.
So yeah, it is more difficult. Part of that with the iPhone, you can say is that because it's a waterproof and so on. But even before it was waterproof, they made it harder. So that came first, making it harder to open it up and repairing it. And that, in a way, makes sense. This is a true story. When they start building the light bulbs, and in 100 to 1910s and 20s, obviously they started, and these bulbs would work for a very short period of time, and then they would go out. People have to buy a new one. They got actually so good that these bulbs could work 5,000 hours. But they went back. That was an illegal thing even then. All these light bulb producing companies got together. They agreed upon to make a bulb that won't last more than 1,000 hours. And they had to do it together, because if one company wouldn't be on board, that company would put literally other companies out of business. This was illegal then, is illegal now, but still was done then. They got in secret, like almost like mafia. They got together, and I'm going to unshare this. They got together and they made this consortium of these light bulb companies, and that consortium fell apart in 1950s actually. That they don't make bulbs that last more than 1,000 hours. Now, I have to, and until 1970s, when you buy like any machine, they're mostly made so robust. Number one, you can take it apart and put it back together with two kinds of screwdriver. And then it's easy to take them apart, put them back together, or repair them. But they don't fail. They just don't fail. And I think everybody knows that your toaster, your machines, and so on, the life expectancy of them is somewhere between 5 and 10 years. And you're expected to replace them.
Yeah, so when you said your compressor is 10 years old, I'm like, okay, well, maybe it's time up.
But there is no reason, no physical reason for that machine to be time up to replace it or to repair it or not working. What I found out is that in this part of the machine that connect that pressure device to where the air from the compressor comes, there's a piece of plastic that has gotten sturdy, that has gotten very, brittle after 10 years. And that part I cannot buy. I have to buy the entire pressure switch, which is, by the way, more than about 1/4 of the price of the.
1/5. It was 100, and buying a new one is 500.
Well, no, new one was 475.
Yeah.
This is just a switch, is $107.
Okay.
So about 1/4 to 1/5, somewhere between 1/4 and 1/5. And I have the feeling, even though nobody will admit that, they're on purpose adding special plastic parts that have a life expectancy in the new machines. The special plastic parts that have a life expectancy, they assure that after a certain point, there is systematic failure. I think this is pre-designed, and I'm not being a conspiracy theorist to say that this is a built-in, this failure of what we buy has been built in because that generates revenue for them. And then and even what we understand now, it is more economic for me to buy a new compressor than literally try to buy this, and then the graphite of the engine was bad as well as was had to be replaced and so on. So it's definitely more economic for me to buy a new one than to try to repair it, even though I know what the problem is. Probably that plastic piece, the absolute economical value of that plastic piece is probably less than 5 cents.
Yes.
So, but then you had a good point. You talked about that, no, first of all, we talked about that. I showed you the video from Pakistan that these are incredibly talented people. The things that are for us, I mean, that would be madness to try to repair, like a total truck or a battery, a car battery. They take the car battery, they take the pieces out. And I'm going to show you a few of these things. And they take it apart and put it back together, and it works.
Car battery.
Yes, let's watch one of that, because I think you don't understand this if you don't see that. I think this is truly, we should watch this together, few of these videos, okay? Yeah. So let's go back here. This is the truck that we watched together, and this, nobody in the sound mind in the US or anywhere in the world would think about repairing this, but they're taking every piece of part of this, and look at that, talking about child labor under this heavy machine. Okay, look at that. Now they're taking every piece apart, they're putting it back together. Those broken pieces, those bent pieces, they put it back together. This truck is going to, at the end of the day, to drive away after they're done. Look at that. That already look more done. Now, here, and this is especially Pakistan. I don't know why these videos are all from Pakistan. Pakistan car battery revival. Here, look at that here. And it's on the corner of the street, they cut here, look at that. They cut the top of that battery.
There's acid inside.
No, they emptied that before. They emptied the acid before. Yeah. And you see that's gloves as well. Do you see that there? Yeah. These are extremely professional, talented people. Now he's going to take every piece out, cutting the connection.
That's graphite?
No, that's lead.
Oh, that's lead.
Yeah, you see, they're cutting the pieces, taking them out, and these are the lead thing, and that he's adding. Look at that, he's adding. No, well, it's lead.
It's lead.
Yeah, it's lead. Adding the connection that they would get together, and while he's doing that, he as well.
Looks like aluminum or something.
No, it is lead. Definitely not aluminum. Because that is not, this is called lead acid battery. Okay, all the connections are lead, and it is easier for lower temperature to work with lead. You couldn't melt lead, aluminum on an oven top like that. You couldn't reach the temperature for that. But look at that, how easy it's cutting it, it's lead. So, and then put those paper between that here. You see, stacking the paper between that as a barrier. And then look at that, cleaning that, connecting them together, stacking them together. And now pouring new connection. Here you are. And then after he's all done, he already have, let me go back here. He already have connected all together, put that top in, and then sealed the top of it. and now he's going to seal if he hasn't, or he has maybe here. He seals the side of the plastic with a hot iron or something. Maybe he has done it before. Right after you put it in. Yeah. So either way, he pour acid in and he has a loaded and he's done. After I showed that to you, you told me something that's very valid. Now, what did you tell me after I told you, look at what they are doing and so on? That I know what I was asking in China, I was thinking maybe there's something similar that that people recycle, reuse lots of more things. What did you tell me?
Well, I mean, it was a popular idea in China that you fix your own thing because we didn't have a lot of things to begin with.
Yeah.
We can't just afford throwing things that are mildly broken. So we would try everything we can to repair them.
Mm-hmm.
But
this is not for yourself. This is a threat. This is, I would say, their way of, these are professionals. These are not fixing our own thing. You look at that, how skilled he was, this person.
No, I mean, as a society, we don't have a lot of things. If we have like a elevator. So I remember when I was growing up, I grew up in an apartment in Beijing City, and there was an elevator operator because elevator was considered a very expensive equipment. Like you can't just go in and press things. Who knows what you can screw up?
Probably kids would just go up and down all the time to use it as a toy or something.
So these equipments are very valuable. So we try to salvage them whenever we can. And later on,
when you were growing up, you're only 25 years old.
Yeah.
So this is not long time ago.
No.
Okay, so go ahead.
So and then we start talking about why it's not a massive practice in China, because
so you're telling me in China is like in US, that truck would be thrown away and you just build a new one?
In most places, in cities, but I'm sure there are people that want to do that, but it's not encouraged, not by the government, and not anymore. One reason that I can think about is there's a set of procedures that you need to follow to assemble things together to reach a certain performance in a certain period of time. So I remember when people say China like to reverse engineer stuff, yeah, that's true. But when we bring stuff to China, we open them up, we try to see what's happening inside them, and we find we can't put them back together. Or if we put them back together, they have very bad performance. And then that's when the engineers realize there's a certain procedure to put stuff together, like which screw to turn first, like how many turns you have to turn the screw, like the torque thing.
Like the torque, how much pressure is on the screw for the system to perform at its peak.
Yeah, as well as like even extreme cases like the environment in which you install the things.
I think if you have the hands up there, it doesn't recognize it. Okay,
so like you have to install it in a set humidity, a set temperature, so that it doesn't bend or expand at the optimal level. We don't know that when doing reverse engineering. These knowledge are acquired through numerous tests that cost billions of dollars.
Yeah, and the idea is, which is very valid. When you do like to repair those trucks, every truck repair is individually different. Every battery repairing it is individual. Though you saw that taking those pieces apart and individually paying attention to those things. Not only that you cannot build a mass production based on those individual skills. Those individual skills are depending truly on very few, very skilled people that you cannot build a huge economy on them.
Yes, those things that you build individually will not have like a unified expectation.
Yeah, and but what I think, what I wanted to, the reason I want to have this podcast now and talk about is that your point is very true. You cannot mass scale it and build a whole economy around that. But I want to talk about how is it the battery first time produced? How is that truck first time produced? It first time produced by such skilled people to who understand so much about intricate combination of how these parts work with each other, and then they find a new way of doing them or putting them together. So I would say, yes, that's not the way to build the economy, but I think we choose all our astronauts that go to Mars from Pakistan, but from those people who are able to take a battery apart, repair it and put it back together, or people who are able to take the whole truck apart, each individual pieces. I want to show you another piece, how they are repairing things that, that would be, unimaginable for us, like the mechanical part of a like a clutch or a broken shaft, or even more like how they repair an electric motor. Like you're familiar with the electric motor that, you have a two coils that they produce electricity and so on. If you see how their depth of knowledge, they may not understand the physical science of it, but if you go back and just watch some of them doing this actual work, it is amazing that the amount of skill in hand skills. And again, I see that always in Pakistan. I don't know why. You know why? Well, these all videos are from Pakistan, that they are repairing all these things.
Maybe because they face the problems that China used to face 30 years ago. They have machinery, but not so much. So they have to cherish them or take extra good care of them, or use them to the fullest potential. Yeah,
look at that here. Like this is there are so many different and a broken shaft. How they repair a broken shaft with the very primitive tools. Actually, I mean, that is the amazing part of it, that they use what we would consider quite primitive tools in a primitive environment to repair this tools here. That is one of the things I think I looked at. And now, to a certain degree, we do with very special tools, that's with very special, engine that they are not produced and they fit to a very special thing. In the United States, we do that as well, because some of these electro engines are like $500,000.
Yes.
And they don't really build that anymore. So they take it out, rebuild it, and put it back, and so on. But these people have taken it to an extra level that, look at that. They individually, like, I want to show you a few of that here. Here.
Handmade.
That is, and that the accuracy you need to truly make it handmade. Like, these are the different coils they are building, all handmade. Okay, and you can't do just one mistake, and the entire thing won't work. Look at that. Now, the first person who built that had this kind of skills.
Yeah, it feels like a college project, like to build one of these or to repair one of these. I think it's normal for necessary for engineering students to do these.
Yeah, but no, certainly for us it's not viable anymore to do things like that. But if you go back, you see like repairing broken shaft. I wanted you to see in what primitive environment they're able to do that. Broken shaft. I have so much, so much really respect for these people, Look at that. This is a broken shaft of whatever tool it is. This is the end result after they repair it. Look at that. Now, the steps to really repair that really matters. And the amount of the skill to take, like they're putting it there and then they're making a hole and many times you see that they're really using it here. He's just adding more metal to it with the old TIG welder. Okay, just adding more metal because it's not long enough. Okay. And yes, you're absolutely right. This will never be as strong as original factory made and will never perform at that level.
Yeah, so you have no idea what kind of impurities are in the metal that he melted.
That is correct. But the point is here,
it gets the job done for a short period of time, like within a year, maybe,
no, but you will be surprised.
Or a couple thousand hours.
No, but
solve immediate problems.
It's going to solve immediate problems. That is why I'm saying, look at that. After he add metal to it, now in the United States we have a similar method to add metal to things, but we have a computer-controlled environment with the gases that protect that. We have all of that. That's what we are good at. We make a science out of everything, and then look at that. He's measuring it and so on with very primitive tools. Okay. Now, but engineering and innovation. So I think there is a mass production, it's a commercialization, and there's a mature economy like China is now. But there is a way to get there.
Yes.
That way to get there starts right there. Starts right there. That people with massive talent, truly master of their work, they just make it something work, often with very primitive tools. And for that reason, I think if you're going to send anybody to Mars, Elon, if you're listening, go to wherever the village this is in Pakistan, all your astronauts should, because these are the people who take the dirt or whatever left over from the rocket and build something else out of it. I'm scared to tell you that this knowledge, these skills are gone. In the United States, it's in the United States are gone. And sometimes I literally use primitive tools to fix things in the war to make the situation work. And that is why my war are very efficient, because in a war, it's not a mass production. Every person is like a very individual piece that's broken, that you have to fix them. You have instruments that are very different instruments that you have all these different situations that are different. And I think that is what I think something that we can teach to our kids. Don't throw things away. If something's broken, take it apart. At least look inside, understand why it's broken and how it's broken. You don't have to even fix it.
I think it's a good idea to experiment from an individual level so that you know how those machine works. But maybe from a corporate standpoint, you don't really want your users to open up these heavy machinery. And
get those special screws.
Yes. They're just trying to stop you from doing that, because what if you mess up and it exploded and you get an injury claim?
Yeah.
I think it's
I don't believe if you really have a chance of that, if you open up, because often, as you know, they put special sticker to open the machine. You have to break the sticker. And if you open it up, then it's all you. It's not on them. That is a legal thing that we can cover. But I think they one of the reasons they add this special situation, so you cannot open things up. Special screws, special kind of
precautions.
Yeah. I think most of that has something to do. They do not want you to repair that machine, because a machine that you repair yourself has add no economical value to them. The machine that you have to replace or repair with them does add economical value to them.
Do you feel the same when you try to open up a Mac? Like you have to use a slide, like a credit card
Very-
or a very thin plastic piece to
Well,
open up the screen. Do you feel
It,
that
u-
way?
it used to be with the Macs that, and that we are turning Macs to PCs and we do a lots of experiment with them and so on. It used to be the same way, but Macs are now so universal that those special tools are now easily available in a way because of the success of the Mac. Those special screws and the screwdrivers and tools are more or less are considered in normal inventory.
Yeah, or maybe there's another explanation that it originated from Steve Jobs being a control freak.
Yes, yes,
He,
that's
he doesn't like when users mess up with his baby.
yes, and it used to be told about that, and that is the Mac produce zero product in the United States. You know that, right?
What was it again? Like Apple?
Apple produces on the factory level zero product in the United States.
I mean, they were made in China, Vietnam, India.
And that is because when it comes to the mass production, you guys can mobilize a whole factory with 10,000 people for a short period of time, and then you wind it down and then produce something else and so on. You're good at that. United States, it's very labor is costly.
Yes.
Okay, but what Max produces is the plan, the program, the whole design, marketing, and so on.
Standard procedure of assembly.
Yeah, and all of that is in the United States, actually in California, and Mountain View, it's very close to Stanford. Cupertino, and then you guys put it all together and so on. But you would be surprised as well to know about the stories behind the Steve Jobs as well and his engineers. The Steve Jobs engineers are like those Pakistani people who take a few pieces together, create a prototype, present it to him. He hated 9 out of 10, liked 1, and that is exactly, this culture to be able to repair things is a breeding ground for innovation and engineering. Being able to understand these mechanical pieces, like one of my jokes is that we are in my lake house. We have a guest house. Did you sleep in the guest house yesterday?
Yes.
Is the fridge working there?
I don't know. I wasn't using the fridge.
Okay, but it is working.
Oh, it's working. Okay.
Because it wasn't working about 2 years ago. And they wanted just a few $100s to come and look at it. It was cheaper to buy a new one. Now I'm going to take a piece, show it to you from that corner. It is the board in the back of the. So our visitor, the people don't see that, but describe what you see in this box, Misha.
A lot of PCB boards.
Yeah, electronic pieces.
Okay.
Right? Yeah, it's hard to see them, but here, electronic pieces. So I'm a trash collector. So this is all trash, right?
Yeah,
Sort of. Now, what if I told you, if you open the back of the fridge in the guest house, there is a circuit board, and one of the capacitors on that circuit board is replaced by one of the pieces here. And that fridge is working now for 3 more years since I have repaired that. What if I would have told you that the circuit board there uses the same capacitor, which makes sense. Why have a different kind of capacitor? Why have the capacitor is a capacitor.
So you replace the capacitor, but not the entire circuit board.
Not the entire circuit board,
So
just the capacitor.
capacitor.
Yes. I took it out of one of these pieces and replaced that, and that is working now for 3 years. And it wasn't really difficult. People think I'm a genius to do that, but I opened it up. It was a capacitor that was exploded. The capacitor is most of the time is like a cylinder.
Yeah.
And when you see that it's bulging out and it's darkened and so on, it is burned out.
Mm-hmm.
Okay. And then if you look at it, there are numbers on it.
So
and
you
then,
find the Same
Yeah.
number. And
How many capacitors do you see here? Just in this box here.
1, 2, 3.
Hundreds here. So, and I was lucky to find another capacitor from an old radio that wasn't in use anymore. And new radios, they don't even, I'm not sure even how they are made anymore, but the old, very old radio. And then with the cassette recorder and so on and so forth. So I took the capacitor out, replaced it, and it's working now. This is meaningless for our, everyday activity, but in situation like that these pieces have a important function, and replacing them takes months sometimes. That becomes a survival thing.
Yes.
And this is one situation. The other situation, if you're trying to innovate new things. If you're trying to innovate new things, then all of a sudden this kind of skills, this kind of knowledge become as well extremely important. That makes a difference between being able to innovate or not.
Yeah, like you have to understand the current system first before you can make improvements.
Yeah. One example, and people who work with me in Crookston, they know that I arrived for surgery, and one of the C-arm, the machine that produced X-ray, it's turning on, but the monitors don't go on. Okay, so the regular thing there is you bring a new C-arm, but there wasn't a new C-arm in the hospital.
No, you tried to see what's going on with the monitor, right?
No, that is not the monitor. It's all inside. Every wire is inside. It's not like these machines.
Oh, okay.
They're not like a regular monitor. They're all the machine. Every connection is inside, and so on and so forth. And and literally, if it is not working, the system doesn't boot up. That are built that way. Okay, so it's non-functional. You need a new C-arm, but there is no new C-arm.
Yeah, they're expensive.
Well, there's only 2 of that in the hospital. And then, and you need both of them.
In the entire hospital, only 2 of them.
Yeah, it used to be.
I thought you need 2 of them to do surgery.
Yes.
Do your surgery.
Yes, I do need. There are 2 of them. One of them is broken. So you have 4 cases. So people want to cancel those cases.
So you got to the hospital in the morning when like 7
a.m.
7 a.m.
They're telling that C-arm is not working. We have to cancel the case.
All the 4 cases. Okay.
So what do you think what happens next?
I think you investigate why it's broken. And
so I open up the back of the C-arm, and then I bypass the fuse of one of the fuses. All these monitors, they run through a system, through a UPC that give them additional electricity that they can, that's a battery and so on. It's all used just that when you disconnect it from electricity, it doesn't just shut down, it just boots itself down, the computer. So because we know if computer that's up, if all of a sudden you shut it down, it just can corrupt the data. But that's what it uses, a battery system and a UPS and a fuse that helps it to have enough electricity that if you disconnect it, it boots itself down rather than just shut down. So what did I do? I bypassed all of that. I connected the computer and monitor directly to wall electricity. And we did all 4 cases. Now,
did they repair the C-arm?
Later on, yeah. Absolutely. And then we bought the 3rd one. So we have one extra. Okay. But that day, that would not have been, none of that would have been a solution that day. That day, 4 people would have been sent 7 hours back because people come from long away to Crookston for this surgery. All those surgeries should have been canceled. All those people who showed up, so much loss of productivity and people's pain, they had to be rescheduled and so on. All my time I drove there and so on would have been lost if I wouldn't have repaired that thing. And it wasn't really a big deal. I just understood the connection between these pieces. How do I know that? How that is built and how it can be like
you were fixing the fridges.
And you have another C-arm in Pearl Plaza. If you go there, the back of it open. It's opened by me. I opened it up and I looked at the operation of all those C-arms. And I just did it because, I wanted to see if I can repair that. It was broken.
Can you repair them?
No, I couldn't repair that because this was the because on that specific machine there is a SCSI driver for old hard drive. That is what it would use. It's not a modern computer. It was made for that, and it was a SCSI driver for a hard drive that is not being produced anymore. It has a special interface that only that kind of card works there. So I couldn't find that thing, or it wasn't worth to try to find it the same way that here you find that, that you pay 1/4 of the price of the whole machine just for one small piece. Okay, but the knowledge I gained, it could have been that, I wasted a lot of time on that C-arm. But the knowledge I gained from that, I opened up the back of the machine, I bypassed the whole fuse and UPS system and connected the actual computer and monitor directly and independently to electricity. We booted it up, we did the surgery, and in that day, back of the machine was open, and the wires were connected to the wall. And but it was working just nicely and beautifully, and people didn't have to live in pain for another few months. And if you don't know it, you're scared. Oh, what is going on back of the machine to the wall and so on? Is it safe? Is it not safe? The most scared people are people who don't understand how things work. Like, would you ever do a heart surgery on a person? You would be scared.
Yeah.
But the cardiac surgeon is not scared doing that. I would be very, very scared to do cardiac surgery.
Have you done it?
No, I haven't. No, but I'm a surgeon, but I haven't. I would be very, very scared to do cardiac surgery. But am I scared to do neurosurgery? No, because that is what I do. Because I know what to look for, what's important, what's not important, and so on. Knowledge is what gives you this freedom to have new adventures, do new engineering, new things, build new things, and so on. So I think the moral of this podcast is that, if this is important to you, make a project. Take your kids. If a machine is broken, you're going to throw it away anyways. Open it up. Be careful. The electricity is important. Don't mess with it. But you don't even have to connect it to electricity. Disconnect it from electricity or anything that goes in and out of it. Open it up and see how the things inside are working. Now, having said that, this is one of the things I just figured out. Again, you don't see that, but these are mechanical pieces, electronic pieces of a humidifier. I figured out that, let me just get my virtual things away so people see actually what we are doing. So this is a piece of a humidifier, and this is the device inside that turns the humidifier off when water level falls below a certain level. And the way it works, this goes inside of a plastic tube. It's all sealed. Outside of the plastic tube is this here, which has a magnet inside. It floats up and down here. So if water is up there, it's outside. But when the water falls here, the magnet activates a switch here that turns the thing on and off. Okay, and I took it all apart. Now I'm a little bit more knowledgeable about that. And you would be surprised how many times similar pieces and devices are used across the board in different kind of machines. Like, a piece of the humidifier or toaster is the same switch that is inside of your dishwasher, is the same that is inside of your car, and so on and so forth. As a matter of fact, some common knowledge is that there's certain switches and parts that only they have one or two producers in the entire world. Everybody buys it and buys them from the same person. Like, if you look at that, you see that these connections, these are standardized connections. And probably there are a handful of people, factories in the world producing, everybody else buys them. And so it wouldn't be unusual, to be able to buy these pieces and or take it from a different machine to use it in a totally different, because again, they're standardized. So I'm a little bit of actually disappointed that China has moved out of that realm of, that pioneer, I would call it pioneer engineering and innovation. But it's good for China, obviously, because that means your time is so valuable. You shouldn't be doing this kind of things.
Yeah, it's just a natural cycle of industrialization. When it would start from workshop and then standardized factory and then something else.
Now, tell me a little, because I hear about that China has now the most advanced railway system and the longest and so on in the whole world. Tell me a little about, when was the last time you were in China?
It was about 2 years ago.
2 years ago.
Yeah.
Now, and you were in Beijing, right?
Yes, I live in Beijing.
Yeah. Now, if you would compare Beijing, the city of Beijing, and the downtown and infrastructure and public transportation, what is the closest city that people in the Western Hemisphere would understand? What city would you compare Beijing to?
From a city outside China?
No, some in Western Hemisphere. What city in Western Hemisphere, like in US or Europe, would be infrastructure, streets, public transportation, railway, airport, and so on? What city would be most comparable? Because I'm sure you have seen more. You have seen Beijing and you have seen other one.
I guess that will be Washington, D.C. and a small part of Chicago downtown. I lived in multiple cities across the United States. I lived in North Carolina, Chicago, California, Minnesota.
Yeah.
And I think it's pretty comparable to Washington, D.C.
Which is pretty, it's the capital of the United States. So which is very advanced.
It's really good, reliable, and clean underground system, subway system.
What about the railways? Intercity railways, because intercity railways are most horrible, terrific thing in United States.
It's
like if you go to Europe, well, there is, but it is.
They're like sightseeing.
Yeah.
Sightseeing.
Nobody really use them. Whereas in Europe, that is the main way for people to transfer from one city to another. In Europe, like in Germany, every little town has a railway connection and so on. And you have this rapid between big cities and so on, rapid railways and so on. First of all, we don't really have rapid rail. What we call here in United rapid railway is what they would call 50 years ago in Germany rapid railway, or maybe even before that. But the railway in China, what is the country that, have you been in Europe?
No, I haven't been, never been in Europe.
Okay. Well,
I've been in China and Japan, which are two countries that are really heavily invested in railway infrastructure.
Now, let's put it this way. I think in Germany they have this intercity rapid rails, which those trains they drive on a regular rails. That is the beauty of it, and they drive around 300 to 400 kilometers an hour.
Sounds about right.
So what are those things in China right now?
In China, there are like rapid rail and standard rail. For standard railway, they travel about 150 kilometers per hour, and for
which is 100 miles an hour. None of our rails drive, they go 100 miles an hour.
High-speed rail, I think the standard is 350 km/h, but they can go to 400 in some cases, or in some newer models. And there's a magnet train in Shanghai
Yeah,
that connects to airports.
they
That's
go-
500 km/h.
but that's not very long. I think.
That's around 20 kilometers, I would say.
Yeah,
Yeah,
that
it's
is
not very
not very long.
It's not. It's a prototype,
Yeah.
I would say.
I think in Japan they have those
Bullet trains.
bullet train. How fast are they?
I think those are around 400-ish.
Mhm.
China, we learn a lot from Japan in
Mhm.
terms of railway construction.
Yeah. So and I guess that is it shows that industrialization level in China is very advanced. I guess.
It's making progress.
Yeah.
It was pretty bad decades ago, and it's not
I think
okay.
Yeah, I think one of the things that's very important is that average salaries are predictive of their industrial evolution of a country. What is the average income of let's say, a average worker in China per month or per year? What do you think? Like the teacher in your school?
It varies a lot based on geography. Like in Beijing,
Beijing, yeah, let's talk about
Beijing, if you want to hire some high-skilled worker, you pay a lot more than you will in some second or third tier cities. So, for example, in Beijing, if you want to hire, what kind of worker are you hiring?
No, well, let's talk about the school teacher or a
School teacher.
a plumber or electrician and so
School
on.
teacher makes about school teacher based on they're paid based on 10 years. Like let's say 5 years into the job, probably earn about, I'll say $1,000 a month.
That is
Give or take
yeah,
$1,000 a month.
Obviously it's much lower than the United States.
But that's a very decent salary in Beijing.
So you can have a mid-class life with that. Middle class life, you can afford regular food. You can have a
if you have a
decent-
place to stay, then you're in middle class. But if you're paying rent, then probably you're on some budget.
No, okay. If I go start living a regular middle class life, not extraordinary, but regular middle class life, how many dollars a month do I need to have a middle class normal life in Beijing?
Again, depends on if you're from there. If you're from there, your parents are there, you have a house there, you don't have to pay rent.
No, I want to go there and rent. I'm going to move into Beijing and rent an apartment, and I want to live there, have another extraordinary kind of life, but a regular life.
Rent, if you want to live in a decent part of the city that's probably $1,000 a month.
Okay, but
So,
another $1,000 to live,
$1,000
and $2,000.
$2,000.
Okay, that is
Which, if you're receiving a Chinese salary, you're classified as a really high-end worker if you can earn $2,000.
yeah, I get that. Now, what do you think is important? What is is it this? And obviously, if you have extraordinary skills, you have to get paid more. I have a theory. I'm not sure if it's correct or not.
Go ahead.
That for economic maturity, obviously, it's important that the skilled worker or worker generally are expensive, because then you automatize things. If people are cheap, there's no reason to automatize things. One of the reasons that in the United States, we get rid of our production is because people who make things, the worker are expensive. So we send them somewhere else. But as well, the same reason that because people are expensive, we put lots of money into automation and robotic and so on. So we have less people to do manual job and so on because they are expensive. And so for economic prosperity, it's important that the workers are expensive, because then you put more money and budget on innovation to automatize and automate processes. But my theory is that though, to kickstart economic boom, innovation, and engineering, it is important to have lots of people who are very skilled, but they are not prohibitively expensive to hire. Like, look at those. It is cheaper, obviously, for those to repair a shaft, broken shaft, and just buy a new one. Otherwise, they wouldn't be doing that.
Yes.
Right. So I'm not sure. I'm not sure where that sweet spot is, but I think if somebody could go to the Pakistan and organize all this brain, all these skills, they could create a tremendous amount of value. And you know what's the proof of that? This has been done in India. Tata. They are richest people on the planet because they exactly did that. In India was the same thing, that lots of skilled people that do tremendous amount of work, but they weren't organized to produce a consistent value that you can sell. Now they have done. Well, we are going to, no, that is one of my daughters. So we are going to call it a day. And everybody, thank you for joining us for this episode of